Okay, good morning, students. It's me, Dil sir. So today I am going to start terms and terminology used in SET, especially for class 10 students. So let me explain terms and terminology used in SET today, and then after I will show you some formula used in the set problems, and I have already written one question, yes, related to the set. So then after we will solve this. So then after you will get the ideas to solve the set problems by using or by knowing the terms and terminologies used in set. Okay, dear students, be ready. Terms and terminologies used in SET. Okay, first of all, some few terms, yes, or words used in SET problems. So that is that is or. Okay, or. I have written here or. So or represent or indicate union. Okay, union, that is A or B, or A or B in this way can be written, that is A intersection B. It means, sorry, A intersection B, not A union B. Similarly, and, the word and used, that is intersection, okay, that is A and B, and symbolically it is written A intersection B, A, okay, cap B. It is also called A cap B, and it is called A cop B because it is in the shape of cop. That's why, yes, we can say A cop B or A cap B. Okay, next next A only, we can write here or cardinal number of A union B, or we can write here cardinal number of A intersection B. And similarly, at least, okay, at least one means, at least one means minimum one and maximum two. Yes, at least one means minimum one and more than one. At least one means, so at least one, this indicates also either dot 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 or dot dot dot. Yes, at least one means either dot 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 or dot dot dot. So symbolically it can be written, suppose at least one, or either either A or B. You can write here either A or B. So it can be written symbolically A union B, or number of A union B. In the case of elements, in the terms of elements, we can write A union B, or in the terms of cardinal number, we can write number of A union B. Similarly, at least one only. Okay, at least one only. At least one only means only one, not more than one or not less than one. We can take only one, only one. So only one means A only, at least one only, it means A only or B only. A only or B only. At least one. Okay, so we can write here n notation A plus n notation B. We can write in this way: n notation A plus n notation B. That means at least one only. Okay, so at least one only, it means either A only or B only. Either A only or B only. So that is symmetric difference. Symmetric difference. It means asymmetric B. Okay, a symmetric difference B. So in this way you can understand the meaning of at least one only, A only or B only. Yes, it can be written n notation A plus n notation B, or in other words either A only or B only, or A symmetric difference B. So the meaning of at least one only, you can write here A only, A only, so n notation A. Similarly B only, yes, can be written n notation B. Okay. Next, neither dot dot nor dot dot. Okay, that means neither A nor B. Neither A nor B. So neither A nor B means that is A union B complement. Okay, complement of A union B, or in the terms of cardinal number we can write here number of A union B complement, or number of complement of A union B. Okay. Similarly at most, I'll use the word at most. Yes, the term at most is also used in this question. You can see here. Okay, you can look here. Who like at most one subject? Okay, at most one. Okay, you can use this term at most one. So at most one means maximum you can take one only. Okay, and minimum none of them. You understand or not? That is. So the meaning of neither nor also, that is none of them. None of them means also number of A union B complement. Okay, none of them also, not at all also, not at all means also number of A union B complement. Okay. So at most one only, at most one means maximum you can take only one, and minimum, yes, not at all. Okay, so at most one means, okay, then at most one, that is at most one means you can take maximum one. Okay, that is only A plus only B plus number of A union B complement. So in the Venn diagram you can see here. Okay, in the Venn diagram you can see here, this is A and this is B. Okay, This is A, this is B, this is A's intersection B, this is only A, and notation A, okay. And notation B, this is number of A union B complement. So besides A intersection B, besides this common part, yes, besides this common part, if you take the values or number of other remaining parts, yes, and their sum will be represented by the term that is at most 1. Okay, so I make the shadow here, I make the shadow here. Okay. Okay. This shaded part, yes, this shaded part represents the word, the term at most 1. So that means according to the Venn diagram, you can use the single symbols or notation that is number of A intersection B complement. So at most 1 means, okay. So in this way you can be clear about the terms and terminology used in set. So again I am going to repeat, that's OR means union, just like A or B can be written symbolically A union B, or in terms of cardinal number, number of A union B. And the meaning of AND, that is intersection, okay, that is A and B, can be written symbolically A intersection B or number of A intersection B. Okay, next, at least 1 means either dot 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 or dot dot. Okay, just like either A or B, either A or B, or A union B. Okay, that means or number of A union B. At least 1 only means A only or B only. Okay, A only or B only, that means number of only A, or N notation A plus N notation B, either A only or B only, or asymmetric difference B. Okay, in the last video we have already discussed about the asymmetric difference B. So I think you may have the confusion, okay, about the asymmetric difference B. Okay. Asymmetric difference B means what? Yes, the asymmetric difference B can be defined as the set of those elements which are either in A only, which are in set A only or in set B only. So that is called the asymmetric difference B. Okay, then A only, it can be written symbolically and notation A, and B only, it can be also written in the written symbolically and notation B. So similarly, neither dot dot nor dot dot. So neither A nor B, that means neither A nor B. So it can be written symbolically the complement of A union B. Okay, and in terms of cardinal number, so number of complement of A union B. So neither dot dot nor dot dot, yes, it does mean also none of them. Okay, none of them, the same symbols, the same meaning. Okay, we should understand. And also not at all. Okay, that means the same neither dot dot no. Okay, don't be confused in the problem solving. Okay, these terms are very important and very essential, yes, while you are going to solve the questions. And at most 1, N notation A plus N notation B plus number of complement of A union B, that is at most 1. At most 1 means maximum you can take only 1. Okay, not more than 1. You are not allowed to take not more than 1. If it does mean more than 1, then we should take the common part also. But we are not allowed to take the more than 1. So at most 1 means only A plus, only B plus number of A union B complement. So it represents the single notation, that is number of A intersection B complement, yes, by the this shaded part. Okay, dear students, you can copy or you can take the screenshot, okay, to copy these terms and terminology used in problem solving. So you can take the screenshot also. For screenshot I will give you 10 seconds. Okay, dear students, now I am going to show you the Venn diagram. Okay, Venn diagram. Okay. Okay, students, I am going to explain the Venn diagram. I think you have already discussed in earlier classes, yes, in class 9 also. So it is not this much complicated to be clear about the Venn diagram, but I will show you shortly, yes, to talk about the Venn diagram. Yes, Venn diagram is the diagram or pictorial representation, okay, of the set and set relation, okay, in terms of elements or in terms of cardinal number, and which is developed by the mathematician John Venn. So the title given to this diagram, that is the Venn diagram. So today we will talk about the Venn diagram. So by the help of Venn diagram, we can show the relationship between the sets, okay, in terms of elements and in terms of cardinal number. Okay, we will talk about the if A and B be two overlapping sets. Okay, overlapping sets is also the set relation between the two sets. Okay, but it has been discussed already in earlier classes, even though I am going to discuss about that. So if A and B be two overlapping sets, okay, then overlapping means both of set must have the common elements. Okay, so we can say that such two sets are overlapping sets. I will show you with the help of the Venn diagram also. And in the case of set, Venn diagram is best tool and technique, okay, to solve the equations. Because if you don't know about the Venn diagram, okay, then in examination hall, yes, you may not have the idea, okay, or you cannot find the idea to solve the questions related to the set. So if you know the Venn diagram, yes, and the part of the Venn diagram and their set notation, then I think you may not have the trouble, you may not have the problem to find or to innovate the idea to solve the such type of questions. And I think, yes, you should not do labor, okay, to memorize the formula. If you know the Venn diagram properly, yes, and I think that it is not needed to memorize the formula of the set. Okay, let me explain. So in the case of A and B and overlapping set. In the case of overlapping, so in this way we can draw the two circles. Okay, so what type of circle is this? Yes, in terms of the geometry, in the case of overlapping, yes, these two circles are called intersecting circles because they intersect at 2 points. So we should take intersecting circles. In the case of overlapping, this is set A and this is set B. Okay, and this is the common part between them. So the set notation of this common part, that is number of A intersection B. Okay, and this part, yes, besides the common part between them, so this part is called the A only, because this part belongs to set A only, not in set B. This part. Okay, so this part has the symbols or set notation, that is N notation A, and this part also, yes, the remaining part of the B besides the common between them, so this part is B only, so it is denoted by N notation B. Okay, and then the remaining part, yes, outer part, that is number of A union B complement. Okay, dear students, you must have the knowledge, yes, at least which part is denoted by which symbols or set notations. Then only, yes, you may not have the what to recall or to remind the formula related to the set. So Venn diagram, yes, is very effective tool that helps us to, yes, solve the problems very easily. Okay, all together Venn diagram. Okay, this rectangular presentation, this rectangular part is represented by the universal set U, and inside this, yes, in the case of two sets, yes, it has altogether 4 parts: 1, 2, 3 and 4. So overlapping does mean that it has the common part. Okay, this is the common, this part is common. So and this part is only A, that belongs to set A only, not B, in not in B, and this part is only B and belongs to in B only, not in A. So and this part, yes, this part is what? This part is called, yes, neither A nor B, or not at all, none of them, this part. Okay, okay, we can define in this way also. Suppose we are going to have a survey. Okay, we can going to have a survey in the class, yes, in the particular class. Then we will divide into the two sets, that is set A and set B, and we can raise some questions to them. Okay, to the set A and to the set B. Okay, if we try to ask, yes, how many of you, okay, how many of you like and dislike coffee or milk, then you may have the some response, you may have some answers. So according to such questions, you can find these values. Suppose A set indicates the number of students who like milk. Okay, who like milk. Suppose this is the milk. Okay, in set A, suppose we will separate those students, yes, who like milk, and in set B, okay, we will raise a question: how many students like tea? Okay, we have the two questions to raise the set A and set B. Yes, how many students like milk, and how many students like tea? Okay, suppose we have a survey and we are going to ask the questions to the particular students of any class. Then we can raise the questions. So how many students like milk, how many students like tea, and how many students like both of them, milk and tea? How many students will like milk and tea? Okay, and then we can raise also the questions. How many students like milk only? How many students like tea only? Okay, in this way we can raise the questions. And how many students like none of them? Means how many students like neither milk nor tea? So such type of questions we can raise. Okay, and you must understand the terms and terminology used only at most. Okay, that is at least one, or at least one only. Okay, such type of terminologies will be used, okay, in the questions, so you can solve. Okay, tell me A union B. First of all, I will talk you number of A union B. What does it mean? Union means what? Union means the arrangement of, yes, the arrangement of elements in set A and set B without repetition. So we can take these three parts as the union of A and B. Okay, union of A and B, A or B. So we can take these three parts. Okay, for the union, yes, these three parts belong to the A union B. These three parts. Okay, keep in your mind, these three parts always belongs to A union B. Okay, so you can easily write here A union B has these three parts, that is only A plus only B plus number of A intersection B. In this way you can find the formula. So not needed to memorize. If you know the real presentation and the set notation of the particular part inside the Venn diagram, then I think you may not have problem, or you may not have trouble to know and memorize the formula. And similarly, you can find this also. Okay, suppose another formula of number of A union B can be found in this way. First of all, I will show you. I will show you here number of A. Okay, number of A. Okay, number of A has two parts. Okay, one is only A, another is common part. So the sum of these two parts is equal to the number of set, is equal to the set A. So you can take these two parts, only A plus number of A intersection B. So from here you can find also only A. Okay, only A has the formula, that is number of A minus number of A intersection B, or number of A intersection B you can find number of A intersection B, number of A minus n notation A, n notation of A, or number of A only. So if you know the base formula, then not needed to derive this one. And similarly, number of B, okay, in this way same. Similarly, number of B, you can write here number of B only plus number of A intersection B. So from here you can find n notation B, that is number of B minus number of A intersection B, or number of A intersection B, you can find number of B minus n notation B. Okay, if you know these two, then you can find the another formula of number of A union B. I will show you here. We have number of A union B, that is only A plus only B plus number of A intersection B. Okay, you can write the formula of this number of only A. Yes, that is number of only, what is the formula of number of only A? That is number of A minus number of A intersection B. In this way, number of only B, yes, we have the formula, that is number of B minus number of A intersection B, and at last we have number of A intersection B. Now by solving this, these two cancel, and we have number of A plus number of B minus number of A intersection B. So this is the another formula of A union B. Okay, dear students, I think you understand easily, okay, because very sweet and very easily I explained here, and I derived the formula related to the when the two sets are overlapping. Okay, then due to the specified time, yes, limit specified time, I am unable to solve this one, but in the next video, okay, I will solve these questions. Okay, try to copy this question, because in the next video I will solve this, and try to copy this also, yes, with the help of the screenshot. Thank you very much.